Okay, so what is the restoring force of a spring, and where is the equilibrium position located? So the equilibrium position, that one's the easiest to start with. So equilibrium is where force of the spring equals the force of gravity. That's where equilibrium is going to be. So if I have a spring and it's got a weight on the end, equilibrium is where the spring's force up and gravity's force down balance out with each other. Oh, so only got the one page. Okay, so what is the restoring force? The restoring force is the force of the spring. Okay, and you can think of that as kind of the spring constant. It's not exactly that. Spring constant-ish. Okay, it's not exactly just the spring constant. It's slightly more complicated. It also has to do with how far you are from equilibrium. But the restoring force, the basic premise is the restoring force is the force the spring exerts. So whatever force the spring exerts, that's how strong the restoring force is going to be. Okay, so let's look at number 2. So we already talked about 3 of these 4, but we didn't explain why. So which of the following affects the spring period of a spring, why or why not? So let's start with spring constant. So I'm just going to go through and explain what the effect is, if any. So spring constant, we said, is inversely proportional. Mass is directly proportional. Acceleration due to gravity has no effect. And amplitude of displacement has no effect. Emma, let's go with you. Why do you think spring constant did matter?
So like if it has a higher spring constant,
Mm-hmm.
it means that it's stiffer, so it doesn't take as long than if it has a lower one.
Yeah, so stiffer springs are going to be stronger, and so they're going to have a larger effect on how it moves. So the way I like to think about it is it's the main cause of restoring force. You know, let's do a different color so it stands out a little better. So it's the main cause of the restoring force. And so because it's the main cause of the restoring force, it is going to be a large factor. So the more strength you have in the spring, the more restoring force you can have. And the more restoring force you have, the faster it's going to move. Excellent. An auspicious start. Dylan, let's talk about mass. So why do you think mass mattered?
I thought mass was directly proportional because I think it has more to do with the effect of the tension of the spring.
Yeah, explain that to me. You're on the right track.
I think the greater the mass, the more it would clear down the tension.
Yeah. So what happens with mass is, up here we said that equilibrium is where the force of the spring equals the force of the gravity. So basically, mass, the idea with mass is it causes the spring, I should say more mass, be more specific here. So more masses causes the spring to work harder. So the reason why mass matters is because while spring constant is what affects the restoring force, that restoring force is less effective if you have more mass because it's heavier. Remember we said inertia a long time ago. Inertia is an obvious tendency to resist change. Objects at rest remain at rest unless acted on by a non-zero net force. If you increase the mass, you increase the inertia, but without increasing the force, it's going to have less effect. The spring constant will. So if you want to move a heavier mass, you need a stronger spring to do that. So that's where those two things come together. Okay, good, excellent. Indy, what about gravity? Why do you think gravity didn't matter?
So I think the gravity is a constant force. So the equilibrium is at the same position. So the balance of the spring is so I think the force is balanced by the force of the spring.
Yeah, good. So force of gravity balances out the force of the spring, right? And so it changes the equilibrium position, but that's all it'll change. It just changes where the spring sits. It doesn't change anything else. If I lift it 1 meter above or 1 centimeter above that point, it's 1 centimeter above it no matter where it is. If I have gravity acting on 3 grams or 10 grams, remember gravity affects all things the same. So gravity is not going to be a factor here because it's basically always going to be balanced out by the spring or by the force of the spring. So gravity is constant. And balanced by the spring. So in space where there's no gravity, the spring force just doesn't need to balance it out at all, and so the spring just moves on its own, whatever it is. Okay? Not any spring would work perfectly in space. You would need a spring that's like already stretched out a little bit. But the basic idea is you don't have to have gravity to make it move. You had to have gravity for pendulums because gravity was partly responsible for the restoring force, right? Gravity is partly what brings it back to equilibrium. That's not the case here. Gravity doesn't make you go to equilibrium, so it doesn't matter for this case. Good. All right, and last one. Ethan, let's go with you. So why do you think displacement or amplitude didn't matter? Yeah, so when you stretch it out further, it goes faster to make up for how far it has to go. So you can think of it as larger displacement gives more energy / speed to compensate for a larger distance. So yes, a spring has further to go if you stretch it out further, but that also means that there's more energy to make it move faster. So those two things will balance out with each other, and that's the idea you get. All right, questions? All right, number 3. For the pendulum lab, we discussed how its speed and acceleration and restoring force change during oscillation. Do those properties behave similarly or differently for springs? And the answer is it's the same. There you go. So we said that as you go towards equilibrium, the pendulum increased speed. It was going the fastest it could go at equilibrium and then slowed down on the way to amplitude and stopped at amplitude before it repeated the process again. Exact same thing for springs. Springs have 0 at the maximum amplitude. They speed up as they go to equilibrium. They're going the fastest they can at equilibrium. Then they start slowing down on the way away from equilibrium back to the maximum or the minimum amplitude, and then they repeat it again. We said that with acceleration restoring force, it was the opposite. You had the maximum restoring force when you were far away on a pendulum, 0 restoring force at equilibrium, and then it went back to a maximum on the other side before repeating. Springs are the same way. Maximum restoring force at the highest amplitude when you compress it up, 0 restoring force at equilibrium because that's where it wants to be, and then it increases again to max down at the bottom side before repeating again. So pendulums and springs, they behave the same way when it comes to speed and acceleration and force. Nailed it. Wow. Back page. Someone out there probably doesn't have a back page. Who doesn't have a back page? There we go.